Good day everyone. In this video, our group will be presenting about seasonal index, which is one of the important tool used in forecasting. The group members are Komalaam, myself, Merlyn, Syafiq, Sathish, Yi Xun and Sarmila. Now, let's look into the definition. What is seasonal index? Seasonal index is a numerical measure that indicates how a particular period, for example, month, quarter, or week, compares to the average of all the period in a year. It captures regular, repeating fluctuation in data caused by seasonal factors such as weather, festival, or consumer behavior. For example, ice cream demand increases during the hot months. The purpose of seasonal index is to remove the seasonal effect or adjust the forecast to reflect the seasonal patterns. Seasonal indices help to understand how demand varies by period. It also helps us to identify the high demand and low demand season. Seasonal index is also help us to adjust the future forecast for planning and control. Moreover, it improves accuracy in production, staffing, and inventory decision. Seasonal indices helps to avoid the overproduction during the low demand. It also helps us to avoid the stockouts during the peak demand. Seasonal index is also eliminating the extra labor cost and excess inventory holding cost.
How to calculate seasonal index? First, we need to collect demand data. Second, compute average demand per period. After that, compute overall average. Get the seasonal index, period average, divided by overall average. So how to interpret? If seasonal index equal to 1, the period is normal, just like the average. If more than 1, the period is above average, so busier. If less than 1, the period is below the average, so slower than normal.
Alright, so we have seen all about the theoretical things on the forecasting based on the seasonal index. Now let's go to the case studies. So case study 1 is COYG Durian Fruit Stall sales team had a task to study on the forecast of the durian sales for 2025. The team had a demand data of year 2022, 2023 and 2024. Since durian sales is based on season, COYG durian sales team had approached seasonal forecasting method to foresee the inventory they need to stock up based on the months for 2025. So basically what we have over here is the demand table for the 2022, 2023 and 2024 from the month January up until December. So the first step, we have to find the average historical demand for each year. So from the table just now we had, right, we have to calculate on the average for each month over here from 2022, 2023 and 2024. For an example, January we have to plus 90 plus 70 plus 95 divided by 3, you get 85. So that's the average for January for the 3 years. Same thing we perform for the February, March and until December. So once we already have the average of the monthly, the next thing what we're going to do is we're going to take the monthly and yearly average demand for overall 2022, 2023 and 2024. So what we will do over here is the first thing is we have to find the yearly average sales, which is demand of 2022, 2023, 2024, all the average we have to sum and we already get the yearly average, right? So from the yearly average 1080 divide by the 12 months we'll get 90. So that's the monthly average of durian sales that required for the monthly average.
Okay, so after calculating the monthly and yearly average, next step we will proceed to compute seasonal index for each month. In order to get the seasonal index, this is the formula that we use. Average divided by the monthly average. For example, January, the average is 85 and the monthly average is 90. So we just divide 85 by 90, so we can get 0.94. The same goes to February, 80 divided by 90, we get 0.89. March, 86 divided by 90, we get 0.96. We continue the calculation for rest of the month until December. After we calculating the seasonal index, then we will estimate the total demand for year 2025. In this case, we target the yearly sales would be 1,260 and equivalent to 105 monthly. We just use 1,260 divided by 12, so monthly we estimate the sales will be 105. After that, we can forecast using the seasonal index that we calculated just now. So to get the forecast value, we just times the seasonal index with the 2025 monthly target. For example, month January, the season index is 0.94. Then we times with 105, we can get 99. Same goes to February, 0.94 times with 105, we get 93. So these are the value that we forecast for the sales in year 2025. These are the two graphs that we plotted. As you can see, the graph in blue color is actually the past sales record, and the graph in orange color is actually the 2025 forecast. These two graphs are actually having the similar shape. The only difference is only the value for each month.
Next, we go for case study 2. The Bratman Collection sales team analyzed Deepavali sales data for product A from 2011 and 12. Given the seasonal nature of the Deepavali demand, the team applied a seasonal forecasting method to project the expected demand for 2013. This analysis enables the team to plan appropriate inventory levels for product A and ensure adequate stock availability during the Deepavali peak season. Below is the data which is collected from previous year, which is the 2011 and 12, which we calculate the seasonal index for the next year based on the 12 months. Next, for calculate the seasonal index, as a first step, we have to find the average historical demand for each year. The formula that we're going to use to find the average is we sum up the current 2 years actual demand and divide by 2. So for example, for January month, we sum 320 plus 390 divided by 2, which is we got average 385. Then for the month February, we sum up 250 plus 440 and divide by 2, which is we got average 345. Then we repeat the same method for all the 12 months to get the averages of the months. Next, as a step 2, we compute monthly and yearly average demand over all 2011 and 12. To calculate the yearly average, we sum up the total average that we calculate from the step 1, which is we got 5,070 year average sales. Then for the monthly average, we use the formula which is the yearly average divide by the total months, which is the 12. So 5,070 divided by 12, we got the monthly average for 123. Next, as a step 3, we compute seasonal index for each month. For compute the seasonal index, we use the formula average divided by the monthly average. So the average we're going to use is the average that we compute on step 1 for every month. Then for January, we use 385 as an average and divide by the monthly average, which is the 423. Then we got the seasonal index 0.91. Next, for the February month, we use 345 divided by the 423. So the seasonal index we got 0.82. Then we repeat the same formula method to calculate the seasonal index for all the month until December month to get the seasonal index.
For step number 4, we can estimate the total demand for year 2013. First, we have to determine the yearly target sale for a company. For this example, the target annual demand for 2013 given is 6,000. Then we can divide the value with the number of months, which is equal to 12, and the value we get is 500. This 500 is the monthly target demand for year 2013. Next, we can calculate the forecasting value using the seasonal index. By using the formula seasonal index times monthly target, for example, in January month, we can take the seasonal index value 0.91 times 500 equals to 456. The next example, for February month, 0.82 times 500 equals to 408. We can repeat the same approach until the month of December to get the monthly forecast value for year 2013. Then, we can plot a forecasting graph using a seasonal index for product A. The below graph shows the past sales history, while the upper graph shows the forecast value for year 2013. In short, the seasonal index helps us spot recurrent pattern, improve forecast accuracy, adjust for seasonal effect, and reveal the true underlying trends, supporting better planning, budgeting, and inventory decision. I think that's all from all of us. Thank you.